Hi everybody and welcome back. I just want to take you through another example of coming up with a vector equation based upon certain information given to us. And remember, in the very first example we did of establishing a plane equation, and I just want to make sure, that I make it clear, we're trying to come up with the vector equation of a plane. And in the very first example, when we did a vector equation of a plane, we did the example of using 3 points, right, to establish direction vectors and position. So in this situation, I'm giving you a different scenario that could be presented to you in terms of the initial information. And your job would be to find the vector equation of the plane based upon this limited amount of information. So here's the information. You can read at the top. It says, determine the vector and parametric equations of the plane containing the point 1, -5, 9 and the line 1, 1, 1, s, -1, 1, 0. So this is one of the preconditions to establishing a plane, is if you have a line and a point, you have enough information to establish a plane. And I've kind of drawn a diagram to show you how it's going to be done. On the diagram, you can see that I have the point right there, -1 or 1, -5, 9, and I have the line right here, right? I have those two things, but then I've done something interesting. I've drawn an arrow from my position vector on my line to the point, and the reason I've done that is because the way that we're going to come up with, we know that a plane has to exist where this would be possible, but the way that we're going to come up with a plane equation is we're going to establish 2 different direction vectors and a position vector. And so all we have to do really to tackle this problem is understand that we need a second direction, because look, we already have one direction in which we can create like a spanning set. So we can call it like, I don't know, vector A. We already have a direction vector A, right? And that direction vector happens to be -1, 1, and 0, right? That's one direction in which we can go along the plane. But then we have to establish another direction vector so that we have 2 different direction vectors, because that's a requirement of a plane equation. At this point, we only had a single line and one other point. So what I can do though is I can create a second direction vector by taking a point that existed on my original line and the other point, P, and create a vector out of them. We'll call that vector B. I guess you can call it whatever you want, or you could call it vector AP, I guess, but I'll call it vector B. And vector B is going to equal, okay, so we remember, like we'll do with this actually. Vector B, okay, we'll get rid of that. Let's make sure we have our, okay, vector B is going to equal the head of the vector, which is the x coordinate, minus tail of the vector. Okay, so we're finding out the vector displacement or direction that's associated with this, okay? Comma the y component, so -5 -1, and then the z component, so 9 -1, right? And what does that equal? That equals 0, -6, 8. That is a second direction vector that is on the plane, and we got that direction vector simply by connecting point P to another point on our line to establish a second direction vector that would then be enough information to say, look, we got 2 different directions that we're going on this plane, and that would mean we could form a spanning set that could capture an infinite number of points on this plane. And so then all we have to do is come up with the equation. Equation of the plane, right, is going to be R, and we'll call it pi, sub pi, that's a normal way to call plane. R sub pi is equal to our position, which we'll just use any point that's on the plane, which is 1, 1, 1, plus s, okay, negative 1, 1, 0, which is the direction vector of our original line, plus t, 0, negative 6, 8, which is the direction component of the new vector that we established. S and t are elements of real numbers. And then our parametric equations would equal 1 minus s. The y parametric equation of our plane would equal 1 plus s minus 6t. How about that? Okay, and the z parametric equation of our plane would equal 1 plus 8t. All right. So now I hope you found that helpful. That would establish for us the vector and parametric equation of the plane if you were given limited information. So watch the video again if you want to just get a little bit more repetition, and then I'll assign some questions out of the textbook to do, and I hope you found this helpful.